All right, grade 11 physics students. I'm sure that already in other classes you have heard about the internal assessment for each class. And in physics, of course, I've been talking about the internal assessment with every unit that we've been doing. We've been brainstorming ideas for research questions all the way throughout. And now is the time that we are going to look at what an internal assessment looks like. So before you do the tasks below, the first thing we need to do is just to understand what the document looks like. What is the meat of that document, okay? And what are the expectations that we're about to see? Your internal assessment is a 12-page document. Ideally, it should be no longer than 12 pages. We're aiming for that as a maximum. If you go over, it's okay. You might lose some points in communication, but let's just try to make sure that it stays about 12 pages. And in such, you shouldn't be spending more than about 10 to 15 hours from beginning to end to set this up. So after doing this workshop, you should be pretty prepared to be functional. And students that really understand what a good IA looks like are able to do this more efficiently. Okay, so this is an IA that a student did at LCS in my first year here that he had many challenges doing this IA, and he was able to do this in the end. He basically came up with this idea, threw away his original idea, and in the last week before the deadline, after a lot of experience, was able to come up with a brand new idea from beginning to end, write this up in a matter of 15 hours. But it was a hard experience because he tried to do the IA without knowing anything about it to begin with and failed first. And then after that process, he understood what he needed to do and it became a very easy IA. So this IA is about a cantilever, a ruler that's hanging off the edge of a table, and using it as a launching tool, like a diving board. Okay, so his research question is, how does the change in length of a cantilever affect the height of an object launched from it? And this would be his title page. Okay, and you would have nowhere on your document should you have your name. Okay, that's to protect your privacy. Okay, and after that, we begin with our introduction. So you'll see in the information below what each section of an IA should have, right? This video here is just to show you the general structure of what an IA looks like. So in your IA, you'd start with a brief introduction to talk about your personal interests, his curiosity, and what drove you into that. Now, of course, he obviously loves going on diving boards and swimming, and you'll see what makes a good introduction and what doesn't make a good introduction in the discussions below. He then focuses on a research question, makes it very, very clear in the form of how does a change in an independent variable affect a dependent variable. And after your research question, you have to build the relationship between the variables by putting in a background information like we do usually in our lab reports. Okay, notice the student uses in-text citations, okay, like you would in your extended essay or personal project. Okay, footnotes and notes. There are references throughout. Okay, it's very nice. Notice also that he has images in his document to help describe the free body diagram or describe visually what's happening in an experiment. You want to use as many images as possible because it saves in your writing. And all images, of course, have titles underneath or captions underneath. All right. So in the background, he develops a mathematical relationship that describes the variables, the independent variable and the dependent variable, and he builds that relationship. So in this case, he's talking about Hooke's law, the restoring force of that cantilever. He explains a little bit about Hooke's law, and then moves into some complicated formula that we've never seen before, but something that he was able to research that relates to the force required to push down the cantilever. And in his experiment, he is changing that length of the cantilever and seeing how it affects the launching of a projectile from the end of that cantilever. So he had to come up with this relationship. He rearranges the equations to be able to develop some type of link. Okay, and as we see, breaking down the investigation, he describes a couple experiments he's doing to link together to come up with the answer. How does a change in that length of the cantilever affect its launching ability? Okay, so here he talks about experiment 1 to derive the K constant and variables in here. Okay, and then after that, he describes that he's going to be using conservation of energy to predict how high that projectile should go in theory. Okay, after that, he outlines the experimental variables in a table form, okay, which helps him build an apparatus and procedure. Look, he's got pictures of his experiment, and it's all annotated annotated, very, very nice. He describes his procedure in paragraph form. You don't have to do this in point form, step 1, step 2. You can summarize it in paragraph form. Okay, and then he describes his data collection. First, he talks about his qualitative observations and how he decided his uncertainties in his experiment. And then he puts it up in a table form with hopefully uncertainties in the table, which is not here. Okay, then he talks about sample calculations. Any calculations you do in your experiment, you'll have sample calculations for. And of course, with our data processing, we will be making graphs and analyzing those graphs. And in his case, he made graphs to be able to do data processing to calculate a K constant for his rulers. Okay, here's a summary graph that he made. Notice that there's error bars in graphs, and he starts the graphs from 0 so he can try to find systematic error. Okay, then he puts a table of process data so that he can move on to the analysis. Wow, okay, and after that, he does some sample calculations for how high theoretically a projectile should go if you know the K constant for that ruler. He makes a theoretical graph, and he compares it with his actual results. So this is the grand finale. This is a graph that shows his theoretical mathematical model results and the actual results, which he can then talk about in a conclusion and an evaluation. This is a very, very high quality IA, and I will be posting it so that you can read it a little bit more in detail, but very, very organized and very, very high quality. All right. And then afterwards, he has his conclusion where he's able to analyze his hypothesis and math model and see if his experiment was a success, and an evaluation where he analyzes the errors in his experiment, something that we've practiced all the way throughout. And then, of course, at the end, he's got a works cited page. So I'm going to be putting this up below. You'll see it down in the links below, and you can read a little bit more about it and get a better idea of what your IA is going to look like. And at the end of the document, what you will see after his appendix, you will see a grading rubric, okay, which you're going to be reading about in task number 1. This grading rubric, okay, has a bunch of the comments. The kid did not get 24 out of 24. Believe it or not, this IA was worth 20 out of 24. So it tells you that this is going to take a bit of a process in organization to get perfect. But that's what we're here for. We're here to help you, okay? So read through the IA, read through the comments. That will get you a better idea of what's coming about. And don't get yourself nervous. Remember, this student worked very hard on an IA and then decided to change his mind at the last minute and put together a very clever piece of work. And all that you saw up there took the student just 5 days to complete because he was very, very clear on what he needed to do and how he needed to write it in the end. Okay, so I know that all of you guys can do this, all right? So in the tasks below, you're going to learn about the requirements of the IA, you're going to learn about each grading criterion and what goes into it, and you're going to see a video from a student that describes how he made a 24 out of 24 IA. And after that, you're going to be doing an activity to be grading a couple IAs together just to make sure you really understand the nuts and bolts before you get going on your own. And then you can be like this student and finish your IA hopefully in about 5 or 6 days once you choose a quality research question. All right, I wish you guys all the best, and I hope this is helpful. And look out for more of these example IAs to help model your own. Good luck.